Um, Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I want to give you a code review. And what I've been doing is I've been practicing on Bert. And Bert is it's a pre-trained model for natural language processing. And so basically, I've been putting off learning Bert for a long time, but now that I'm learning TensorFlow, Bert is part of the TensorFlow family, so I had to learn Bert. Anyway, because I'm still learning, I had to look at other code. I will say that I didn't have a lot of success looking on the documentation, and I did receive some criticism on my Medium blog post saying that you're supposed to look at the documentation, but sometimes the documentation doesn't give you what you want to know, and as a result of that you have to look at other people's code. But fortunately, I did find some code that I wanted, and so I had to use that code to help me prepare this program. So just letting you know that, obviously I didn't make it up. It was a college student, or he had a BS in computer science, and he is the one that designed the code. So I had to use his code to help me with this. So I'll go ahead and carry on with the code review. We're using TensorFlow Bert to identify spam emails. And basically, the first thing we're going to do is we created our program in Google Colab, which I really like Google Colab a lot, but it doesn't have a very good undo function. So you need to make sure that you don't accidentally overwrite or delete code. If you do, you might be able to go into the save history to retrieve the code, but that isn't always possible, and I found that out one time. So after I created my program, then what I did was I imported my libraries. And so I imported pandas as PD, that's your data processing, NumPy as NP, that's your numerical computations, matplotlib.pyplot as PLT, that's data visualization, and Seaborn as SNS, and that's statistical data visualization. And I, as a matter of course, import those 4 libraries automatically every program I write. Then I loaded the data set, and I got this data set off of GitHub. Some people were kind enough to put their data sets on GitHub. So it's delimited by a tab. So the delimiter is the \T to let you know it's a tab. And I use pandas to actually read the file. And so when you read the file, you can see the type is either ham or spam, and then the message. Okay, so now what we're going to do is we're going to replace ham is going to be 0 and spam is going to be 1. So if it's 1, then that means it's spam. It's spam. And the reason why I did that is because the computer wants to see numbers, and so I could have label encoded it if I wanted to, like use sklearn to label encode it, but since it was only 2 values, a ham or a spam, I just made ham 0 and spam 1. So you can see now it's numbers, and the computer likes numbers. Check the shape, 656 rows by 2 columns. Check the size, it's 1312, and you get the size by multiplying the rows by the columns. And then I defined my x and y variables. So your y variable is your target or your label. So your y variable is df type, and your x variable is your message. df message, and your x variable is your independent and y variable is dependent. And so we put the y variable under value counts, so we have 577 zeros and 79 ones, which means 79 of the messages are spam. Now what we do is we use Seaborn to put it on a disk plot, so you can see that there's a class imbalance. We have a lot of ones and a lot of zeros and not very many ones. So now this is what's really interesting with this Bert formula, with this Bert model, is you don't really have to do any data processing. So I assume that all of the data processing is done in the Bert model. So the only thing we have to do is we have to split the data set. So we split the data set XY stratify equals Y. And I'm assuming that if you don't set the test size, then it will automatically set it up to a certain percentage, and I believe it's 20%. So we have our X train shape is 492 by 0 or by 1 column really. X test shape is 164. X test shape is 492, and XY shape is X test shape is 164. So we see that that's right. And now we're going to use Bert and TensorFlow. So that's what's interesting about this model, is you don't have to do any data processing. It's all done in Bert. So you can see, it's all done in Bert. Okay. And now what we're going to do is we're going to import the libraries for TensorFlow. So import TensorFlow as TF, import TensorFlow Hub as Hub, and import TensorFlow Text as Text. And then we have to decide what models we want. So we've got Bert process equals hub.carousel, and then it gives you the file web address for Bert for carousel, and Bert encoder equals hub carousel, and it gives you the web address for Bert encoder. And the thing is that in Kaggle, I received an email about Kaggle, and they're going to start putting models in their programs. So I'm assuming that since Bert is a model, I'm assuming that you're allowed to put models into Kaggle, and I'll have to try that out, because I'm going to try this program out on the disaster tweets and see if I'm getting any success with the disaster tweets. I will say I've been working on this a lot for a couple of days, and it was very frustrating. The reason why it was very frustrating is because TensorFlow has undergone a lot of revisions. And because TensorFlow has undergone a lot of revisions, like the code that you look at from just a couple of years ago is obsolete. And that's another problem, because you look at obsolete code and then you're trying to find some code that's not obsolete to help you. But I did find this code that's not obsolete. And even if you look at code like 2 or 3 years ago, it's no longer usable. And so that's another reason why you need programmers to stay abreast on the revisions of the software. So now we're going to initialize the Bert layers. Text input equals tf carousel.layers.input shape. df type dtype equals tf string, name equals text, preprocessed text equals Bert preprocessed text input, outputs equals Bert encoder preprocessed text. And now we initialize our neural networks. L equals tf.carousel.layers dropout 0.1, name equals dropout, outputs equals pulled output. L equals tf.carousel.layers.dense 1, that means you're going to have just like one output. Activation is sigmoid. That's what you're going to have when it's a binary classification. And name equals output and then out. And then create the model. Model equals tf.keras model. Inputs equals text input. Outputs equals L. And then we check our model summary. So you've got your model summary, and it's quite complex. Now we're going to compile our model. We're going to establish our metrics. Equals tf.keras.metrics, binary accuracy, name equals accuracy, comma, tf.keras.metrics, precision, name equals precision, tf.keras.metrics, recall, name equals recall. So model equals compile, optimizer is atom, loss is binary cross entropy, and metrics equals metrics. And now we fit the model, which is called training. And I will say it was only 10 epochs, but it took a long time to do it. It took a long time to train it. So Bert takes a long time to train. Now we evaluate the model. ypred equals model.predict x test. ypred equals ypred flatten. So if you don't flatten it, then all the values are going to be vertical, and so it's going to be hard to see it on the screen. So that's why you flatten it. And then you look at ypred, and you can see that all of the values are not very high. So what I did was I put a few statistics in there, and this is what I did. He didn't do it. But we checked the minimum value, the maximum value, and the mean. So that's just some statistics that I put in there. And now we're going to create logic. So, and this is something I did. And the reason why is because the maximum value is 0.49. So if the maximum value is 0.49, then you're not going to get any ones. And so there's something wrong there because I tried it on another model and on another code and it didn't work. So there's something wrong there. It doesn't calculate it very highly. And so I said cutoff equals ypred.max minus ypred.min divided by 2. So that's your cutoff. And then ypred equals NP where ypred greater than cutoff 1, 0. And then you check and then you check the array and you've got some ones in there. Now we check our accuracy, and this is a formula that I made. So, and the accuracy is 94.5%. Put it on a confusion matrix. We had 143 zeros and 1 1 that should have been a 0. And we had 12 ones and 8 zeros that should have been 1. So that was okay. This was an imbalanced class set. And the person who I got the code from, he was doing something like, he was trying to make the number of ones the same as the number of zeros, but I didn't want to do that. There's a lot of things that you can try to do to improve the imbalanced class set, but I just stuck with this really. Made a classification report with, this was his sklearn, and the confusion matrix was also sklearn, so you can see the classification report. And then what we do is we compare the actual values to the predicted values. So that was pretty good as well. And that's it. So this was what I did on some spam emails. And what I'm intending to do is I'm intending to take this Bert model and put it on Kaggle's, identify the disaster, and hopefully we'll get some good news there, you know. So I'm going to go ahead and close this video, and I hope that you got some information on Bert, and I'm intending on making a blog post on that too. So Thank you so much for watching my video and my code review. Obviously, I'm studying TensorFlow and I'm studying Bert, so this is completely new to me. And it's good for me to do a code review because it helps me review the code, get greater understanding of the code, and hopefully it helps you to get a little bit of understanding of how to use Bert and TensorFlow, because that's my next big project. That's the big project I'm working on now, is Bert and TensorFlow. So thank you so much to my subscribers for supporting my channel. Thank you for watching my video. If you like my video, please like, subscribe, and share. And I look forward to making more code reviews for you in the future.